The members of our Ballistic Pendulum project are Maggie, Asare, Ankit Bhattacharyya, and Amanda Kott. The bob of our pendulum was built out of two pieces of wood that were connected in an L shape with Velcro attached to catch the tennis ball. Holes were drilled in it so a rope could be attached, and a meter stick was put above the pendulum for reference. The pendulum's starting height is 0, and then when it gets hit by the projectile and goes up to the part where it starts to change directions, that's going to be the new height, which we're going to use in our calculations.
For the use of a scale, it was found that the mass of the tennis ball was 0.064 kilograms and the mass of the pendulum was 0.347 kilograms. The video taken of the collision was entered into the tracker software where it analyzed the position of the tennis ball and pendulum before and after the collision to determine the velocity of the tennis ball. As seen on the right, the velocity versus time graph displays the velocity of the tennis ball throughout the video. A sudden decline is seen around 0.18 seconds where the collision between the tennis ball and wood plank occurred. The velocity before the collision for the tennis ball was 19.35 meters per second and 3.151 meters per second afterward. By using a meter stick as a reference, it was found using tracker that the change in height from the starting position was 0.01 meters. The momentum before the collision was calculated out to be 1.238 newton seconds, where the velocity of the pendulum was 0 since it was at rest. The momentum after the collision was calculated to be 1.295 newton seconds since the velocity of the tennis ball and pendulum were the same at the end of the collision. Kinetic energy before the collision came out to be 11.98 joules, where the velocity of the pendulum was 0. Kinetic energy after the collision was calculated out to be 2.04 joules, where the pendulum and tennis ball were considered as a single entity. The potential energy before the collision was 0 joules as the starting height of the tennis ball and the pendulum was considered to be 0 meters, and the potential energy after the collision was calculated out to be 0.04 joules.
Momentum was conserved as there's a small difference between the two values of 1.238 kilograms times meters per second and 1.295 kilograms times meters per second. It appears that energy was not conserved since the kinetic energy after the collision is vastly greater than the potential energy of the tennis ball and pendulum at the height of 0.01 meters above the starting height of the pendulum. During the collision, it was found that the change in kinetic energy was negative 9.94 joules. This is expected since the collision was perfectly inelastic, where momentum is conserved but kinetic energy is not. There was a 4.473% difference between the pre-collision and post-collision values for momentum. This is well under the acceptable limit of 10% and suggests that momentum was for the most part conserved throughout the collision. The change in kinetic energy of negative 9.941 joules during the collision was most likely the result of kinetic energy transferring into other sources of energy such as heat and sound. Energy experienced a percent decrease of 98.025% from after the collision to the max height. This was most likely a result of the very low number calculated for the potential energy of the pendulum one at the max height, since a value of 0.01 meters determined by tracker seems unlikely to be the change in height after watching the video.